Good day, sir and classmates. Today, we, the Group 5, are going to discuss light and architectural lighting systems. The reporters are first, Mark Joy Dominic Pavo, second, Justine Dion Agapay, third, John Robert Batas, fourth, Princess Vina Lercana, fifth, Prates Joshua Campilan, and sixth, or last but not the least, is Mary Francis Torrente. We have Mark Joy Dominic C. Pavo for our first reporter and will discuss about illumination and units of illumination, terms on lighting, sample problem on utilization coefficient, etc., and lighting systems. First, we have the illumination. So the other word for illumination is illuminance, and its symbol is capital letter E. It is the intensity of light per unit area. It is measured by the normal luminous flux per unit area received by it. It measures the intensity of light that reaches an area, helping us understand how well lit that space is. This measurement is often expressed in units like lux, which indicates the amount of light per square meter. It tells us how bright that area is and is measured by the amount of light received per square meter. So these are the formula. E is equal to that symbol divided by A, where E is equal to illumination, that symbol is equal to luminous flux, and A is equal to area of the surface being illuminated. So these are the units of illumination. So we have system of units, luminous flux, area, and illumination. So for the system of units, we have MKS, and the luminous flux is lumen, the area is m squared, and the illumination is lumen per m squared is equal to Lx or meter candle. For the CGS, the luminous flux is lumen, the area is cm squared, and the illumination is lumen per cm squared is equal to photh, pH. And the English, for the luminous flux is lumen, the area is feet squared, and the illumination is lumen per feet squared is equal to foot candle Fc. And please take note that 1 foot candle is equal to 10.76 lux and 1 foot is equal to 10,000 lux. Now, let's proceed to the terms of lighting. First, we have number 1, light, or kung sa Bisaya pa, kalamdag. It is the energy radiated in the form of waves which produces the sensation of vision to the eyes. It may be natural light from sun or the artificial light from the means created by human beings. So we all know nga ang light dako kadyo gamit sa atong kinabuhi. Because I believe that without light, we can't see nothing. So therefore, light is important in our lives. Second, visible light is that part of electromagnetic radiation spectrum capable of exciting the retina and ultimately producing a visual sensation. It describes how our vision works. It explains that we see because our eyes detect energy that travels as waves, such as light. These light can come from natural sources like the sun or from artificial sources created by humans like light bulbs. Essentially, light is essential for our ability to perceive our surroundings visually. So third, brightness. It is the intensity of sensation resulting from viewing light sources and backgrounds. It defines brightness as how intense or strong the light appears to our eyes. It refers to the level of light coming from a source or reflecting off a surface, affecting how we perceive the illumination in our environment. Essentially, higher brightness means a more intense light sensation. Fourth, color. It is defined as the quality of visual sensation which is associated with the spectral distribution of light, Visible light can have length between 4000 A to 7500 A or Armstrong. It defines color as the visual experience we perceive based on the specific wavelengths of light. The range of visible light that humans can see spans about 400 nanometers violet to 750 nanometers red. Different wavelengths corresponds to different colors, and our perception of these colors depends on the distribution of light's spectral components. Fifth, glare. It is a strong, steady, dazzling light. So this is an intense and uncomfortable light that can be blinding or distracting. It often results from bright sources of light, making it difficult to see properly. Glare can come from sunlight, headlights, or reflections, and it can affect visibility and comfort. Sixth, reflection factor or coefficient of reflection or reflectance. Its symbol is a small letter p. It is given by the ratio of luminous flux reflected from a small area of a surface to the total flux incident upon it. It depends upon the characteristics and the color of the surroundings. Example, walls and ceilings, etc. It is the measure of how much light is reflected off a surface compared to the total amount of light that hits it. It's calculated as the ratio of the reflected light to the incoming light. These factors varies based on the surface's properties, such as its color and texture, as well as the characteristic of the surrounding environment, like walls and ceilings. So these are the formula. P is equal to reflected light divided by incident light. Another formula, P plus alpha is equal to 1, where alpha is equal to absorptance of the surface. And please take note, it is always less than 1. Its value is 0 for ideal black body and unity for perfect reflector. Seventh, transmittance of an illuminated diffuse reflecting surface. Its symbol is big letter T. It is defined as the ratio of the total luminous flux transmitted to it to the total flux incident on it. It measures how much light passes through that surface compared to the total light that strikes it. It's calculated as the ratio of the transmitted light to the incoming light. This value indicates how effectively a surface allows light to pass through, influencing the brightness and visibility of the area behind the surface. 8. Absorptance. Its symbol is alpha. It is the ratio of the light absorbed versus the light striking the surface. It is the measure of how much light a surface absorbs compared to the total light that hits it. It is calculated as the ratio of absorbed light to the incoming light. This value indicates how effectively a surface converts light energy into other forms, such as heat, rather than reflecting or transmitting it. Ninth, coefficient of utilization or utilization factor. Its symbol is small letter n. It is the ratio of the lumens actually received by a particular surface to the total lumens emitted by the luminous source. It is the ratio of the actual amount of light in lumens that reaches a specific surface to the total amount of light emitted by the light source. This factor indicates how efficiently the lighting setup delivers light to a given area, taking into account losses due to factors like reflection, absorption, and distribution. So these are the formula. N is equal to luminous flux received divided by luminous flux emitted, where luminous flux received is equal to total lumens received by the working plane, and luminous flux emitted is equal to total lumens emitted by the light source. For the factors affecting utilization factor, We have kind of lighting system, type and mounting height of the fittings, color of surface and surrounding, and shape and size of the room. The utilization factor varies from 0.10 to 0.40 for indirect lighting system and 0.40 to 0.60 for direct lighting system. Number 10. Maintenance factor. Its symbol is a big letter M, F. It is the factor related to the cleanliness of the lamp, including the room, replacement of lamp, after recommended life, etc. It accounts for the effects of cleanliness and maintenance on lighting performance. It includes factors like the cleanliness of the lamp and the surrounding area, as well as the timely replacement of lamps after their recommended lifespan. A higher MF indicates better maintenance, which helps ensure that light levels remain effective over time. So these are the formula. Maintenance factor is equal to illumination when everything is new divided by illumination under actual condition. For the factors affecting maintenance factor, we have dust, dirt, etc., and blacking of filament. Light emitted decreases. The maintenance factor varies from 0.60 to 0.80. 11th, depreciation factor. Its symbol is a big letter D, F. It is the reciprocal of maintenance factor. Its value is more than unity. It is the inverse of the maintenance factor, or MF, meaning it represents the decline in lighting effectiveness due to factors like dirt, accumulation, and lamp aging. Since DF is greater than 1, it indicates that light output decreases over time if maintenance is not performed. Essentially, it quantifies how much light performance is reduced relative to optimal conditions. So these are the formula. DF is equal to initial candle meters divided by ultimate candle meters on the working. We also have another formula where DF is equal to LLD multiplied by LDD multiplied by RSDD multiplied by LBO, where LLD is equal to lamp lumen depreciation factor, LDD is equal to luminaire dirt depreciation factor, RSDD is equal to room surface dirt depreciation factor, and LBO is equal to lamp burnout only for two or more luminaries. The expression for gross lumens required taking into consideration the utilization and maintenance factors. We also have another formula. Luminous flux is equal to E multiplied by A divided by N multiplied by MF, where E is equal to illumination, A is equal to area of the working plane to be illuminated, MF is equal to maintenance factor, and N is equal to utilization factor. 12. Specific output or light efficiency or efficacy. It is the ratio of the luminous flux to the power intake. Its unit is lumens per watt, or LM over W. It measures how effectively a lighting source converts electrical power into visible light. It is calculated as the ratio of luminous flux in lumens to the power consumed in watts. The unit of measurement is lumens per watt, or LM per W, indicating how much light is produced for each watt of energy used, with higher values representing more efficient lighting. So these are the formula. Efficacy is equal to lumens output divided by wattage consumed. The average efficacy of various types of lamps. we have the type of lamp, and the lumens per watt. For the fluorescent lamp, we have 50 to 80. In incandescent lamp, 14 to 20. A mercury lamp is 40 to 70. Metal halide lamp, 60 to 80. Sodium lamp, 90 to 100. And tungsten halogen lamp is 16 to 20. And now, let's proceed to the sample problem. Problem number 1. A room 8 meter by 12 meter is lighted by 15 lamps to a fairly uniform illumination of 100 lux. Calculate the utilization coefficient of the room given that the output of each lamp is 1,600 lumens. So, ang atong gipangita kay utilization coefficient. Okay, so in order to find the utilization coefficient, we must know first the luminous emitted and luminous received. So, mag-una ta sa luminous emitted. So, sa luminous emitted, mao ni siya ang kahayag nga gipagawas sa light source kung pila ang total. So, therefore, ang 15 lamps i-multiplied nato sa 1,600 lumens. So, 15 multiplied by 1,600 is equal to 24,000 lm. So, mao ni siya ang value sa luminous flux emitted. And then, karon kini na pong luminous flux received. So, we all know na ang luminous flux received na formula nga E multiplied by A, where E is the illumination multiplied by A or the area. So, na naman tay illumination nga 100 lux, and then ang area kay 8 meter by 12 meter. So, therefore, makuha na nato ang luminous flux received. So, 100 multiplied 8 by 12 is equal to 9,600 lm. So, ang formula in order to get the utilization coefficient is N is equal to luminous flux received divided by luminous flux emitted. So, i-equate na to. So, 9,600 divided by 24,000. So, is equal to 0.4. Or in percentage, our final answer is 40%. So, with that, nakuha na nato ang answer sa utilization coefficient. Let's proceed to problem number 2. So the illumination in a drawing office 30 meter by 10 meter is to have a value of 250 lux and is to be provided by a number of 300 watts filament lamps. If the coefficient of utilization is equal to 0.4 and the maintenance factor is equal to 0.9, determine the number of lamps required. The luminous efficiency of each lamp is 14 lm per W. So, ang atong gipangita ingani kay number of lamps. So, in order to find the number of lamps, first we must find the luminous flux total, wherein ang formula kay illumination multiplied by area divided by coefficient utilization multiplied by maintenance factor. So, let's equate. So, 250 multiplied by 30 by 10 divided by 0.4 multiplied by 0.9 is equal to 208,333.33 lm. And then, we must find also the luminous flux lamp. So, same ra gihapon sa ganiha, kung giunsa nato pag pangita ag luminous flux emitted, so same ra ni siya. Where luminous flux lamp kay 300 multiplied by 14. So, ang makuha na tong answer is 4,200 lm. So, with that, masolve na nato ang number of lamps required. So, ang formula kay luminous flux total divided by luminous flux lamp. So, atong equate. Ang answer na to is 208,333.33 lm divided by 4,200 lm. So is equal to 49.60. And then kung atong i-round up, a total of 50 lamps. So that is the final answer. Problem number 3. A football pitch 120 meter by 60 meter is to be illuminated for night play by similar banks of equal 1,000 watts lamps supported on 12 towers which are distributed around the ground to provide approximately uniform illumination of the pitch. Assuming that 40% of the total light emitted reaches the playing pitch and that an illumination of 1,000 lux is necessary for television purposes. Calculate the number of lamps on each tower. The overall efficiency of the lamp is to be taken as 30 lm per W. Assume unity maintenance factor. So, kini nga problem kay dapit-dapit kani sa problem number 2. So, pare-parehas sila og gipangita gihapon ang number of lamps. But the difference kay ang luminous flux total i-divide pa nato og ka 12 kay since there are 12 towers nga gipang distribute. So our solution will be luminous flux total. Ato na naman siyang ilargo ha. So mao ni siya ang formula. Natay 1,000 multiplied by 120 by 60 divided by 0.4 multiplied by 1. So our answer will be 18 by 10 raised to 6 lm. So parehas ang gingon ganiha nga ang answer ingani atong i-divide og 12. So ato ni siyang tawgon og luminous flux tower. So is equal to 18 by 10 raised to 6 divided by 12. So our answer will be 1.5 by 10 raised to 6 lm. So ato na pong kuhaon ang luminous flux sa lamp. So same ra gihapon sa atong gibuhat ganiha. So natay 1,000 watts multiplied by 30 lm per W. So therefore makuha nato ang 30,000 lm. And then mo na to sa formula or sa in order to get number of lamps, mo na to ang atong answer sa luminous flux tower i-divide nato sa luminous flux lamp. So it will be 1.5 by 10 raised to 6 divided by 30,000. So our answer will be 50 lamps or tower. So dapit-dapit ka dyan siya no, pero ang process sara ang nagkalahi-lahi. Problem number 4 and our final problem. A school classroom 7 meters by 10 meters high is to be illuminated to 135 lux on the working plane. If the coefficient of utilization is 0.45 and the sources give 13 lumens per watt, determine the total wattage required, assuming a maintenance factor of 0.8. Determine also the number of fittings required. Discuss roughly the lighting plan of the room, showing suitable positions for fitting. Use light fitting of 200 watts. So first thing first, ato sang pangitaon ang luminous flux total. So these are the formula. E multiplied by A divided by N multiplied by MF. So ang E nato kay 135, ang A 7 by 10, N kay 0.45 og MF kay 0.8. So ato ni siyang i-total tanan, ang answer will be 26,250 lm. So inigma na ni atong pangitaon ang total wattage. So ang atong luminous flux total atong i-divide og 13 since there are 13 lumens. So 26,250 divide 13 is equal to 2,019.23 watts. So since atong gipangita kay number of fittings required man, so ang kining atong answer sa total wattage ato ning i-divide og 200 since kung makabantay mo sa last sentence, use light fitting of 200 watts man kuno. So to eliminate also the unit of watts, mo nang fittings na lang hibilin. So therefore, number of fittings required is equal to 2,000.23 divided by 200. And the final answer will be 10 fittings. And now, let's proceed to the lighting systems topic. So first, the characteristics of good illumination. So the following are the characteristics of a good illumination. So first, the light source should not strike the eyes of the worker. It is the importance of avoiding direct glare or bright light from a source that can cause discomfort or damage to a worker's eyesight. Proper lighting should ensure visibility without causing strain or distraction. Second, the type and size of the lamp should be correct. The lamp used for lighting should be appropriate for the specific environment and task. The type of lamp affects the quality and color of light, while the size influences how well it illuminates the area. Proper selection ensures adequate brightness, minimizes shadows, and enhances overall visibility for safety and productivity. Third, the location of light sources should be proper. Light sources should be strategically placed to provide optimal illumination without creating glare or shadows. Proper placement enhances visibility in work areas, reduces eye strain, and ensures safety by illuminating important tasks and pathways effectively. Fourth, reflecting equipment should be suitable. The reflectors used in lighting fixtures should be designed to effectively direct and distribute light. Suitable reflecting equipment enhances the efficiency of the light source, minimizes energy waste, and helps achieve uniform illumination in the space, contributing to a better visibility and comfort for the user. So, mo to sadya ang characteristics of good illumination. So, second, advantages of correct illumination. So, naay tulo. So, first, factory production increases. Correct illumination in a factory enhances productivity by improving visibility, which allows workers to perform tasks more efficiently and accurately. Well lit environments reduce mistakes and the likelihood of accidents, leading to smoother operations and increased output. Second, accidents decrease. So, correct illumination significantly reduces accidents by providing clear visibility of hazards and work areas. Adequate lighting helps workers see obstacles, machinery, and safety equipment, lowering the risk of slips, trips, and falls, as well as improving overall workplace safety. Third, wastage of jobs decreases. Correct illumination minimizes the wastage of jobs by enabling workers to see clearly and perform tasks accurately. Good lighting reduces errors and rework caused by poor visibility, leading to higher quality output and better resource utilization. This efficiency ultimately saves time and materials, contributing to a more productive work environment. So, mo na siya ang advantages of correct illumination. The third, advantages of a well-designed lighting scheme. So there are three. First, adequate illumination. So adequate illumination ensures that all areas are sufficiently lit to support tasks effectively. It enhances visibility, allowing workers to see clearly and perform their jobs without strain. This level of lighting promotes safety, reduces errors, and improves overall productivity by making it easier to focus on tasks. Second, avoidance of glare and hard shadows. Avoiding glare and hard shadows in a well-designed lighting scheme improves visual comfort and clarity. Glare can cause eye strain and distraction, while harsh shadows can obscure important details and create hazards by minimizing those issues. Workers can maintain better focus, reduce fatigue, and perform tasks more accurately and safely. And third, sufficient uniform distribution of light all over the workplace. So, sufficient uniform distribution of light throughout the workplace ensures that all areas receive consistent illumination, reducing the likelihood of dark spots or overly bright areas. This balance enhances visibility and comfort, allowing workers to move and perform tasks without difficulty. It also promotes safety by making hazards easily visible and contributes to a more pleasant work environment. Fourth, factors affecting illumination. So there are four. First, brightness. Brightness is the perceived intensity of light in a space, influenced by the type and wattage of the light source, the distance from the source, the reflectivity of surfaces, and existing ambient light, all of which are crucial for comfort and productivity. Second, contrast. It is the difference in brightness between an object and its background, which affects visibility and clarity. Higher contrast improves recognition and focus on tasks, while low contrast can make objects harder to distinguish, leading to potential errors and decreased productivity. Fourth, glare. There are two types of glare: direct glare and indirect glare. Glare is excessive brightness that causes discomfort and reduces visibility, which can be classified in two types, which is direct glare, where light shines directly into the eyes, and indirect glare, where light reflects off surfaces, both of which can negatively impact comfort and productivity. Fourth, diffuseness. Diffuseness refers to the even distribution of light across a surface, minimizing harsh shadows and glare. It enhances visibility and comfort by ensuring that light is spread out rather than concentrated in one area, contributing to a more pleasant and safe environment for tasks. So, mo to sila ang upat. So, for the fifth, artificial sources of light. Different methods of producing light by electrical means are the following. So, there are three. First, by temperature incandescence. By temperature incandescence, this method involves heating a material, typically a filament in a bulb, until it glows and emits light due to its high temperature. Common examples include incandescent bulbs. Second, by establishing an electric arc between two carbon electrodes. By establishing an electric arc between two carbon electrodes, this method creates light by generating an arc of electricity between two carbon electrodes, producing a bright and intense light. It is often used in applications like searchlights and arc lamps. Third, by electric discharge. So these methods involves passing an electric current through a gas, causing it to emit light. Examples include fluorescent lamps and neon signs, where the gas ionizes and produces light as a result. And now, let's proceed to the kinds of systems. Direct lighting. In this type of lighting, most of the light falls directly to the surface or the spot which is required to be illuminated. In this system, about 90% of the total light energy falls on the object. Indirect lighting. In this case, light does not reach the surface directly but it is being reflected or say indirectly illuminated. The lamps are either placed behind a cornice or in a suspended opaque bowls. In this case, about 90% of light energy falls to the ceiling and then it comes to the object. There is an opaque reflector below the lamp. This type of lighting is used for decorations purposes in cinema, dancing halls, etc. Semi-direct lighting. This system utilizes luminaries which send most of the light downwards directly on the working plane, but a considerable amount reaches the ceiling and walls. Semi-indirect lighting. These lighting systems lies between the direct and indirect lighting, wherein the light is partially received by diffuse reflection and partly direct from the source. In this system, about 60 to 90% light upward and remaining downwards. This type of lighting is mostly used for decoration purposes. General diffusing system. In this lighting system, luminaries designed to distribute light almost equally in both downward and upward directions. These create a balanced and uniform illumination throughout the space, minimizing shadows and providing a comfortable environment. It is often used in areas like offices, classrooms, and public spaces where even lighting is essential for visibility and ambience. Lighting systems can be further classified in terms of the following. First, percentage of light that falls downward towards the work plane. This classification focuses on how much light is directed towards the work plane. Systems with a higher percentage of downward light are ideal for task-oriented activities, while those with a lower percentage may emphasize ambient lighting. Second, percentage of light towards the walls and ceilings. This classification considers how much light is reflected off walls and ceilings. Systems that direct more light upwards create a softer, more diffuse illumination, enhancing the overall brightness of the space while minimizing harsh shadows. So, these are the table. We have type of lighting system, percent downward and percent upward. So for the direct, we have 90 and 10. Semi-direct, 60 and 40. General diffuse, 50-50. Semi-indirect, 40-60. Indirect, 10-90. I think that would be all for my topic. I hope you have learned a lot. Thank you for listening. Padayon Future Engineer. And once again, I am Mark Joy Dominic C. Pavo. And now, let's move forward to our next reporter. We have Justin Dion Agapay. And his topic will be objectives of good lighting design and color rendering index and its application.
Objectives of a good lighting design. For a good lighting design, the following have to be met. First, in accordance with code requirements in the architecture and interior design. Looks good. Provide the proper amount of light in every room. Be built and constructed within budget. Environmentally responsible and efficient. Produce good color. Achieve the desired moods of each space. Proper control of lights. Facilitates daily functions and tasks such as eating and working. Enhance the communication. Lastly, easy to maintain. In accordance with code requirements and architecture and interior design. Lighting design must be meticulously aligned with code requirements and principles of architecture and interior design. By understanding the local regulations, integrating lighting and architectural features, ensuring appropriate lighting levels, and prioritizing energy efficiency, you can create a safe, functional, and aesthetically pleasing environment. Collaboration with professionals and careful planning will further enhance the effectiveness of the lighting design, resulting in harmonious and compliant space. Second, it needs to look good. A successful lighting design that looks good involves a thoughtful blend of ambient, task, and accent lighting, carefully chosen fixtures, and strategic placement. By considering color temperature, quality of light, and the integration of smart technology, you can create a visually appealing environment that enhances the overall aesthetic while providing functionality. Thoughtful attention to these elements will result in a space that not only looks beautiful but also feels comfortable and inviting. Third is to provide the proper amount of light in every room. Each room benefits from a tailored lighting approach that considers function, ambience, and safety. Using recommended lux levels as a guideline and layering different lighting types will help create a comfortable and well lit home. Fourth is to be built and constructed within budget. Balancing quality, functionality, and cost efficiency in lighting design is achievable with strategic planning. By focusing on energy efficiency, prioritizing essential lighting, and simplifying installations, you can achieve an effective lighting setup within budget. This approach not only ensures a cost-effective installation, but also supports long-term financial savings. Fifth, it needs to be environmentally responsible and efficient. Environmentally responsible lighting design reduces energy use, supports sustainability, and considers the long-term impact on both people and the planet. By focusing on efficient technologies, sustainable materials, and responsible design practices, lighting can be both eco-friendly and effective, supporting a healthier environment and lower operational costs. Sixth is need to be produce a good color. Good color in lighting enhances the visual appeal and functionality of a space. By focusing on high CRI fixtures, appropriate color temperatures, and adjustable options, you can create lighting that reveals colors naturally and suits the ambience and needs of an environment. This approach results in visually appealing and versatile space where colors appear vibrant and true to life. Seventh, it needs to achieve the desired moods of each space. To achieve the desired moods in each space, focus on layered lighting techniques, appropriate color temperatures, and adjustable lighting options. By thoughtfully planning lighting design, you can enhance the functionality and emotional impact of each area, creating environments that feel comfortable, energizing, and calming as needed. 8. The proper control of the lights. Proper control of lighting involves a combination of technologies and strategies that enhance user experience, energy efficiency, and adaptability to different activities and moods. By implementing dimmers, smart systems, zone controls, sensors, and user-friendly interfaces, you can create a dynamic and efficient lighting environment tailored to the specific needs of each space. Ninth, it needs to facilitate daily functions and tasks such as eating and working. Effective lighting design is essential for facilitating daily functions and tasks in various spaces. By focusing on appropriate task lighting, color temperatures, and adjustable controls, you can create environments that enhance comfort and productivity, making everyday activities like eating and working more enjoyable and efficient. 10th is to enhance comfort and communication. To enhance comfort and communication through lighting design, focus on creating inviting, adjustable, and warm environments across various spaces. Layered lighting, appropriate color temperatures, and dimmable options contribute to a sense of well-being and facilitate better interactions among individuals. Thoughtful lighting design not only improves the aesthetic appeal of spaces but also plays a crucial role and fostering connection and comfort in everyday activities. Lastly, it needs easy to maintain. To create a lighting design that is easy to maintain, focus on selecting durable fixtures, using energy efficient LED technology, and designing for accessibility and simplicity. Incorporating smart technology and establishing a regular maintenance schedule can further enhance ease of upkeep. By prioritizing these elements, you can ensure that your lighting remains functional, efficient, and visually appealing with minimal effort over time to time. Color rendering index application. So this table shows the minimum lamp CRI and its application. So for less than 50 CRI is for non-critical industrial storage and security lighting. For 50 to 70 CRI is for industrial and general illumination where color is not important. For 50 to 79 CRI, offices, schools, and recreational spaces where color is not important. For 80 to 89 CRI is for hotels, restaurants, offices, schools, hospitals, and retail where color quality is important. Lastly, for 90 to 100 CRI is for retail and museum, gallery, where color quality is critical. Thank you for listening. Padayon Future Engineer.
And now, let's proceed to our next reporter. We have John Robert Batas. He will be discuss about color temperature of a light source and color temperature applications.
Color temperature, in the context of light sources, refers to the appearance of the light described in terms of the temperature of an ideal black body radiator that would produce light of the same color. It measured in Kelvin. A higher Kelvin value indicates a cooler, bluer light, while a lower value signifies a warmer, more yellowish or reddish light. For example, think about the color of the sunset. The sunset has a warm color temperature, which is why it appears red, orange, and yellow. In contrast, the winter sky has a cool temperature, which is why it appears blue or white. Color temperature is important in many different fields, such as photography, lighting design, and television production. For example, photographers use color temperature to create different moods and atmospheres in their images. Lighting designers use color temperature to create different effects in theatrical productions. And television producers use color temperature to ensure that their show look natural and appealing to viewers. So, that's a brief overview of color temperature. To gain a deeper understanding, we will use the Kelvin scale, which you can see here on the next slide. The Kelvin scale measures color temperature ranging from warm to cool. As you can see, the scale is represented by a color gradient, starting with warm red and transitioning to cool blue. Understanding color temperature is important for various reasons. In photography, it helps achieve the desired mood and atmospheres in your images. Lighting designers use it to create specific effects in theatrical productions. Even when choosing light bulbs for your home, you will find different color temperatures, like warm white or cool white, affecting the overall ambience of your space. So, the Kelvin scale provides a way to measure and understand the color of the light. By understanding color temperature, we can better control the appearance of our images, lighting, and even our surroundings. Now that we've explored the Kelvin scale, and how it measures color temperature, let's delve into the practical implication of warm light and cool light. This next slide illustrates the key differences between these two types of light and their common applications. On the left side of the slide, we see a representation of warm light. As you can see, the living room depicted is bathed in a warm, yellowish glow. This type of light is known for its calming and inviting qualities. It creates a sense of relaxation and comfort, making it ideal for spaces where people want to unwind and feel ease. Now let's look at the right side of the slide, which showcases cool light. The bedroom in this image is illuminated by a cool bluish light. This type of light is associated with alertness, focus, and clarity. It's often used in spaces where people need to stay energized and concentrated, such as offices and hospitals. Notice the difference in mood and atmosphere between the two images. The warm light in the living room creates a cozy and welcoming ambience, while the cool light in the bedroom feels more stimulating and functional. This difference in mood and atmosphere is a direct result of the color temperature of the light. Understanding the difference between warm and cool light can be beneficial for various aspects of our lives, whether you're designing a home, choosing lighting for your workspace, or simply trying to create a specific mood. Selecting the right type of light can significantly impact the overall experience. Now that we've established the basics of color temperature and its impact on ambience, let's look at some real-world examples. This slide showcases different light sources and their typical color temperatures, along with their effect on mood. First, let's examine the common light sources listed here. Incandescent bulbs with a color temperature around 2700 Kelvin emit a warm, yellowish light, often associated with a cozy and relaxing atmosphere. Fluorescent bulbs, on the other hand, have a color temperature around 4000 Kelvin, producing a brighter, whiter light that can feel more stimulating and functional. LED bulbs are versatile and available in various colors, allowing for customization. For example, a 3000 Kelvin LED bulb would emit a warm white light, while a 5000 LED bulb will produce a color white light. Finally, daylight, with a color temperature around 6500 Kelvin, provides a natural, balanced light that can be considered a reference point for accurate color representation. Moving on to the impact of color temperature on mood, we can see that warm light, like the light that emitted by incandescent bulbs, creates a relaxing atmosphere, making it ideal for winding down and creating a sense of comfort. Conversely, cool light, often found in fluorescent bulbs or daylight, enhances alertness and concentration, making it suitable for workspaces or tasks that require focus. By understanding the impact of color temperature on mood, we can make conscious choices about the lighting we use in our homes, workspaces, and even public spaces, whether we're aiming for a relaxing atmosphere or stimulating environment. Selecting the appropriate color temperature can significantly influence the overall experience. Color temperature application. So ganiya, atong gidefine ang color temperature, kung unsa na siya makaapekto sa atong ambience ug sa functionality sa atong space. So karon, ana ta sa ijang application. Understanding these applications is essential for designing lighting solutions that match the intended purposes of each space. So sa next slide, namoy makita niyo chart. Kini nga chart is about the application of different color temperatures in lighting. Color temperature nga measured in Kelvin. na ay color temperatures below 2500 Kelvin, color temperatures between 2700 Kelvin to 3800 Kelvin, color temperatures between 2950 Kelvin to 3200 Kelvin, color temperatures between 3500 Kelvin to 4100 Kelvin, color temperatures between 5000 Kelvin to 7500 Kelvin. Sa mga next slide, atong tagsa-tagsaon ang mga color temperature ranges. Color temperatures below 2500 Kelvin produce a very warm, dim light giving off a soft, almost orange glow. This light isn't as bright as higher temperature and isn't designed for creating a cozy or inviting environment. This lighting is typically used in industrial or security settings where very bright, intense lighting isn't needed. So sa color temperatures between 2700 to 3000 Kelvin give off a warm, soft light with a slightly yellowish tint, similar to traditional incandescent bulbs. This lighting range is inviting and cozy, making it perfect for creating comfortable and relaxing atmospheres. Because of this, it's commonly used in places like homes, hotels, restaurants, and even certain office spaces where a relaxed ambient is important. Color temperatures between 2950 to 3200 Kelvin provide a warm but more neutral light compared to the lower color temperatures. This lighting range is often used in places like retail stores and galleries, where it's important to highlight products or artwork without altering their true colors. Color temperatures between 3500 to 4100 Kelvin create a light that neither too warm nor too cool, striking a balance that's bright, clear, and functional. This lighting range is commonly used in offices, schools, hospitals, and some retail environments because it provides enough brightness to keep people alert and focused. Color temperatures between 5000 to 7500 Kelvin produce a very cold bluish light. This intense lighting isn't common for everyday spaces because it can feel stark and uncomfortable. However, it's essential in specific environments where seeing true, precise colors is critical. For example, this lighting is often used in laboratories, visual inspection areas, or places where exact color discrimination is required.
Thank you for listening. Padayon Future Engineer. And now, let's move forward for our next reporter. We have Princess Vina Lercana. She will be going to discuss about light source selection, light sources, incandescent, halogen, fluorescent, etc., and luminaries, downlights, primary rating types.
Light source selection. In light source selection, there are two important measurements of a good light source. Number one is color rendering index or CRI. Describes the quality of light on a scale of 0 to 100. 0 means horrible and 100 is perfect. A higher CRI means that colors appear more natural and accurate. For example, a CRI of 100 means that the object looks like they are illuminated by sunlight. A lower CRI means that colors are distorted and unnatural. Second, color temperature describes whether the light appears warm, neutral, or cool. The term temperature refers to the light emitted from a metal object heated to the point of incandescence. The higher the temperature, the whiter or cooler the light source appears. So, is a way to describe the color appearance of light, especially how warm or cool it looks. Color temperature, it comes from the way of metal object glows as it heats up. Color rendering application. So this table explaining the relationship between the CRI of a lamp and its suitable applications. Less than 50, non-critical industrial storage and security lighting. These applications don't require accurate color rendering, so a low CRI is acceptable. Next is 50 to 70, industrial and general illumination where color is not important. So again, accurate color rendering is not crucial in these settings. 70 to 79, offices, schools, and recreational spaces where color is not important. So in 70 to 79, a slightly higher CRI ensures a more natural appearance, but accurate color rendering is still not priority. Next is 80 to 89. Hotels, restaurants, offices, schools, hospitals, and retail where color quality is important. So in 80 to 89, in these environments, accurate color rendering is essential to create a pleasant and inviting atmospheres. Next is 90 to 100. Retail and museum or gallery where color quality is critical. So in 90 to 100, these applications demand the highest level of color accuracy, making a CRI of 90 or higher crucial. So the higher the CRI, the better the color rendering. For applications where color is crucial, a lighter CRI is essential. Color temperature application. This table correlates color temperature, which is measured in Kelvin, with different lighting applications. So first is less than 2,500, bulk industrial and security lighting. So these applications often prioritize functionality over color accuracy. So a very warm, reddish light is suitable. Next is 2,700 to 3,000. Residences, hotels, restaurants, theme environments, and some commercial office spaces. In 2,700 to 3,000 Kelvin, this warm white light creates a cozy and inviting atmosphere, making it ideal for residential and hospitality settings. Next is 2,950 to 3,200. Display lighting in retail and galleries. This lightly worker white helps showcase products in a more natural and appealing way. Next is 3,500 to 4,100. Offices, schools, hospitals, some retail. So in 3,500 to 4,100 Kelvin, this neutral white light is similar to daylight, providing good visibility and more balanced color rendering. Last is 5,000 to 7,500. Special applications where color discrimination is critical, uncommon for general lighting. So the last is this cool white lights is used in specific situations. More accurate color representation is paramount, such as in scientific or medical settings. In light sources, there are many different types. First is incandescent lamps, also known as an incandescent light bulb or incandescent light globe, is a type of light that works by heating a filament until it glows. The cost of incandescent lamp is cheaper. The color rendering index is considered to be 100. In incandescent lamps, there are a 5 types number. One is standard A lamp, is a popular bulb shape. Second is reflector lamp. These are lamps which contain an internal reflector coating to direct light in one direction. Third is tubular lamp, also called showcase lamps. These lamps were developed for lighting inside showcases. Fourth is globe lamp, is decorative lamp used in bathrooms, sconces, marquee lighting, and decorative fixtures. Last is PAR lamps. PAR means parabolic aluminized reflector. These are lamps with parabolic aluminized reflector. Second types of light sources is tungsten halogen or halogen lamps. Is an incandescent lamp that has a small amount of halogen such as iodine or bromine added. The CRI of this is 95 to 100, and this land of lamp is wide variety. In halogen lamps, there are different types of halogen. First is BT lamp, is intended to replace the standard incandescent lamp. Second is double-ended T lamp. This lamp commonly used in flood lights and torches. Last is single-ended T lamp. These lamps use in specialty architectural and theatrical equipment. And also, there are types of low-voltage halogen lamps. First is MRI-16 and second is compact T3 lamps. These are compact, bright lamps, excellent reading, work and display light sources. The color temperature are 2900 to 3100 Kelvin. Third different types of light sources is fluorescent lamps. Is the same light output, it consumes lesser energy than an incandescent lamp. Fluorescent is limited to indoor usage. So in fluorescent lamps, there are types of this. Number 1 is T8 standard lamps. Standard general lighting lamps available lengths are 2, 3, 4, and 8. Next is T5 standard and high output lamps. One of the most energy efficient, good color light source for general lighting. Available lengths are 2, 3, 4, and 5. Third is T12 standard lamps. Old standard for general lighting, it is no longer used. Last is T2 miniature lamps, useful in tight locations. So fourth different types of light sources is new technologies. In new technologies, there are two. First is LED lights. LED lights is latest and most exciting light source yet invented. Most likely light source of the future. LED lights is very high efficiency, very long life and no radiation. Second is fiber optics as special effects. So, and emitting fiber twinkle effects or star fields in water effects or ponds and water features. Fiber optics can be used to create lighting effects in projects. For example, in photography, you can use fiber optics to any design made of light or wispy smoke effects or phantom spotlighting. Luminaires. In luminaires, there are common types. First is recessed down lights. Are often cans or high hats. Most downlights allow for trims that fit into the housing. Used in a wide range of residential and commercial applications, such as in lobbies, halls, and other finished spaces. Recessed downlights is generally inexpensive, very popular, and good for task lighting. In downlights, there are primary rating types. First is thermally protected luminaires. Second is IC or what we called insulated ceiling. Third is damp location luminaires. Fourth is wet location fixtures. 5 is spa or shower fixtures. 6 is emergency fixtures. The second luminaires common types is adjustable accent fixtures. Allow light to focus in art, signage, and other interior surfaces and features. So, in adjustable accent fixtures, there are two types. First is recessed accent fixtures. Appear as downlights but Internally permit horizontal and vertical rotation of the lamp's light beams. Second is track lighting system. Allow for flexibility in lamp types and easy of relocation using a single power source. Third luminaires types common is wall washer. Wall washers are any type of asymmetric luminaire that is intended to flatly light the wall from the ceiling down to the door. A lighting technique that uses indirect vertical light to create a uniform wash of light on a wall. Fourth common types of luminaires is wall gazing fixtures. Wall gazing fixtures is a technique that places the light source very close to the wall, accentuating a textured surface. 5 luminaires common types is troffers, are widely used in offices, stores, schools, and other commercial and institutional facilities for general lighting in work and sales areas. Troffers are the most common type of fluorescent luminaire. Next is linear lighting systems. Linear lighting systems are fluorescent luminaires having indirect, semi-indirect, and indirect lighting distribution. They are designed to illuminate offices and other more finished spaces because the luminaires can be obtained in varying lengths and assembled into patterns. They are called linear systems. Linear lighting is ideal for helping to illuminate walls, rooms, and hallways. Next is indirect cove fixtures. Provide uplighting onto a ceiling plane. Example of this is that LED tape lights. Sagaran na siya ibutang kay sa kwarto para daw aesthetic tan-awon. So next is task lights. Task lights are especially designed to illuminate a desk area while minimizing viewing reflections. It can be surface mounted on walls or ceilings or can be suspended from ceilings. Flexible in location, quantity, and aiming angles. So task lighting is a type of lighting that provides concentrated light to help people complete specific tasks. Last is decorative lighting. Decorative lighting is the jewelry of architecture in many building types, plays a significant role in building style, period, or motif. So in decorative lighting, there are types of this. First is the chandelier, pendant, close to ceiling luminaires, sconces, vanity lights, torches, table and floor lamps.
Thank you for listening. And now, let's proceed to our next reporter. We have Pritz Joshua Campilan. He will be discuss about lighting controls, techniques, and recommended levels of illumination.
Hello guys, this is Fritz Campilan and my topic is lighting controls, technique and recommended levels of illumination. So, what is lighting controls? The term lighting controls is typically used to indicate standalone control of lighting within a space. So, so aron masabtan po na tong ang gisulti, here are some types of lighting controls. One is switch. So, switch is a control device that turns lights on and off. The two most common switches types are toggle and decora. Example nga ni is kanang mga switch sa atong buy. So, mara na. Next is timer switch. So, timer switch is a switch that turns lights off automatically after a certain period. Next is occupational sensors. Occupational sensors are automatic switches that turns lights on when motion is detected. So, ang kanang occupational sensors murag mga mawar po ni siya sa timer switch. kay pareho sila automatic. Pero ang kalahian nila is occupational sensors is mo detect mo si jaog na si jay ma-detect nga motion. Og ang timer switch pod is ma-on na rin mo si ja, and then after a certain period of time is ma-off na pod si ja. Now, dimmers. Dimmers are control devices that vary the light level and power the lights. So, ang dimmer ko na is na-connect ko ni siya sa suga nga fixtures. O gigamit ni siya pang-adjust sa kakusgon sa suga. Daylighting controls. Daylighting controls features photoelectric sensors that turns lights off or dim when there is sufficient daylight. Now, here are the symbols of the switches. First is single pole switch. Ang symbol nga ni is S. Next is tugang single pole switch. The symbol na is S sub 2 or 2S. Next is trigang single pole switch. The symbol of this is 3 sub S or 3S. Next is three-way switch. Symbol of this is S sub 3W. Next, last is four-way switch. The symbol of this is S sub 4W. Now, proceed ta sa lighting fixtures. Surface-mounted fixtures exposed but remain close to or flush with the ceiling of wall. So, ang kana is popular ni sila sa hallways and bedrooms. Makita na to sila diha. And if installed at wall, it is called as sconce lighting fixtures. Pendant fixtures. Pendant fixtures is suspended by a cord, chain, cable, or other means and are popular over tables, kitchen islands, and in higher ceiling areas. So, diyan na to sila makita. And then, track lighting. Track lighting can be surface mounted on walls or ceilings or can be suspended from ceilings. Flexible in location, quantity, and aiming angles. So, this is used from museum for good reason. So, agkanin nindot po ni siya pang lighting in condos. So, motto. Portable fixtures. Portable fixtures defined typically by their cord, which can be plugged into any available electrical outlet. Now, here are some accent lighting techniques. First is, should be located at about 30 degrees off vertical relative to a focal point. Second is, do not get too close to wall, normally 24 inches minimum away. Use 30, 60, 90 triangles to determine optimum position. Last is, only use lighting systems capable of hitting above 40 degrees off vertical in special situations. Now, let's go with the lighting layers. Focal layer is typically used to highlight vertical surfaces and three-dimensional objects including architectural features and details, artwork, retail displays, and signage. Task layer is used to illuminate specific tasks that are performed in a space, like reading on a table. Daylight layer uses daylight to reduce artificial lighting. Decorative layer, it serves no purpose other than to catch the eye and to make statements about style or wealth. Ambient layer provides the background lighting that helps create the mood of the space. Now, let's proceed with my next topic. Recommended levels of illumination. First, what is illumination or illuminance? Illuminance is a quantity of light or a unit used to measure the intensity of light hitting a surface, typically a wall or floor in lighting design. And the unit of illuminance is lumen per meter squared, or simply lux. And now, here are a few examples which can help us understand the illumination value. Now in the first table, as you can see, we have factories and workshop. First is rough work. Example, frame assembly of heavy machinery, that is 150 lux. Next is medium work. Example, machine parts, engine assembly, vehicle body assembly, that is 300 lux. Next is fine work. Example, radio and telephone equipment, typewriter and office machinery assembly, that is 700 lux. Very fine work. Example, assembly of very small precision mechanisms, instruments, that is 1500 lux. Next is powerhouses. Boiler house, turbine house, conveyor house, switchgear and transformer chambers is 100 lux. Next is control room, that is 300 lux. Next is offices. First is reception, that is 150 lux. Conference room, general offices, and typing rooms is 300 lux. Next is drawing offices, that is 400 lux. Next is school and college. First is classroom, lecture halls, workshops, and library, that is 300 lux. Second is sewing rooms, drawing halls, and art rooms, that is 150 lux. Common room stairs is 150 lux also. Now let's proceed to storage places. First is loading and unloading, that is 40 lux. Next is general stores, that is 100 lux. Last is stores of very small items is 300 lux. Next is sports grounds. A is stadium, that is 300 lux. B, football field, that is 200 lux. Next is tennis court, that is 400 lux. And last is canteens, that is 200 lux. And that's all, guys. Thank you for listening.
And now, let's proceed for our final reporter. We have Mary Frances Torrente. She will be discuss about sample lighting controls, techniques, urban living trends, and challenges of green design.
Good day, everyone. Now we will be going to have some sample calculations based on the given examples from the reference. Here, we will be going to compute the required lighting level, the total lumens of the fixtures presented in a master's bedroom with a floor area of 33.56 square meters. It is stated here that the required lighting level is 5034 lumens and the total lumens of the given fixtures are 1 times 1800 lumens plus 7 times 800 lumens, which is equals to 7400 lumens all in all. But before diving into the step-by-step calculations, let us define some terminologies first, starting with the lighting levels. Okay. So lighting levels, according to NOAO or the National Optical Astronomy Observatory, the lighting level or illuminance is the amount of light measured in a plane surface. So simply saying, the lighting level canal, which is measured in lux, depends on how much light a room needs based on its use. dili na po ni siya literal nga sa room ra. Napod tay mga task. For example, when we are reading, we need a higher required lighting level because kanang kung taas-taas ang atong lighting level, that means malas ang hago sa atong mata ug dili pod ma-strain ang atong mga mata. But in other scenarios, in other tasks, for example, sleeping, when we are sleeping, na may uban nga mga tao nga di ganahan og hayag, kumatog sila, ganahan, mas prefer nila og medyo dim, or some other people, some people kanang kuan jud di pud sila ganahan nga nagisuga at all. So therefore, they need a lower lighting level para makatubog ayo. So, mao na siya nga atong mga examples sa lighting levels.
Lumens. Lumens are measures of the total amount of visible light to the human eye from a lamp or light source. The higher the lumen rating, the brighter the lamp will appear. This simply means that lumens, it is the total light output of a bulb or fixture. So kumbaga, mao ni siya ang katibuk-an nga kahayagon or kung unsa kahayagon ang gigawas sa isa ka bumbilya or isa ka fixture. On the other hand, the lux is a measure of the amount of light level intensity, which is commonly referred to as unit of illumination on a surface area. This simply means that the lux is the amount of light per square meter, indicating how well lit an area is. So nagpamatuod ni siya nga kung ato i-compare ang gamay nga space og ang dako nga space nga room, bisan pa kun og pareho na sila kadaghanon og lumens, makaingon ta nga mas dako og lux ang gamay nga space.
And lastly, the fixtures. Fixtures is also known as light fitting or luminaire, which is an electrical lighting device containing one or more light sources, such as lamps and all the accessory components required for its operation to provide illumination to the environment. All light fixtures have a fixture body and one or more lamps. So pasabot ang nganing fixtures mo na siya ang mga luminaires or ang mga like mga instrument nga makahatag og kahayan. Mura na siya. Okay, we're done defining those terms. So let us proceed to the calculations of the required lumens, the required lighting level, and of course the total lumens of the fixtures. And now, the formula to calculate the required lumens for a space depends on the illuminance level or the lux level, and of course the area in square meters of the space. So the formula here is lumens equals the illuminance level or the lux level times area. So di naman ta maglisod ingani kay according to the example na naman ta diri nga 150 lux times 33.56 square meters is equals to 5,034 lumens. Since naa naman tay given dinhi nga lux level of area, ang atong buhaton na lamang kay simple multiplication na lamang. So, natay 150 lux, diri naputay 33.56 square meters. So, atong i-multiply silang duha, mo answer na siya og 5,034 lumens. So, dili naman ta maglisod ingani kay na naman tay given nga lux level of area, but sa other na situation na may uban nga dili na tumakit-an ang lux level, dili given. Pero ang total lumens niya given. So atong buhaton niya na magmanipulate ta sa formula. So kaning ikaduha na to nga formula may pwede na to gamiton, which is the lux level para makita ang lux level. The formula to calculate the lux level is equals to the total lumens all over the area. So, maura na siya. Pwede ta magamit nga nag-shift solve, pwede po atong manumanuhan. Okay. So, naa naman tayo mga given diri ang ato na lamang buhaton is simple calculations. So, ato na lamang i-times given nga lux level o gag area. Natay 150 lux dinhi na po tay 33.56 square meters. So ato na silang i-times, mo answer na siya og 5,034 lumens. Dili na ta maglisod ingani kay na namatay given nga lux level and area. But in other situation, nay kanang times nga dili na to given ang lux level. Pero ang lumens or the total lumens kay given. So ang atong buhaton ingani atong i-manipulate ang formula. from the formula nga lumens equals lux level times area, mahimo na siya the lux level, or the formula to calculate the lux level is equals to the lux level equals the total lumens all over the area. So, mora na siya, pwede ta magamit nga na og Ship's law, pwede po ta og magmano-mano na lamang para makuha na to ang iyang lux level, or depende na kung unsa gipangita. And we're done finding the required lighting levels. So let us proceed to the fixtures and the total lumens of the given fixtures. But first, basahon sa nato ni. The total lumens output of a light fixture can be calculated if you know the luminous efficacy of the bulb. So what is luminous efficacy? The luminous efficacy measures how many lumens a light source produces per watt. So, na-denote ni si Ja sa LM all over W, or lumens per watt. And the formula to find the total lumens of a fixture is equivalent to the wattage, or W, times the luminous efficacy, or the lumen per watt, where wattage, or W, is the power consumption of the light bulbs in watts, and the luminous efficacy is the lumens per watt for a type of bulb. According to our given here, nga mga fixtures, natay 1 by 32 watts circular fluorescent lamp and 7 by 13 watts CFL pin lights. So, mo na si J given. According sa given diri ang ato dang 32 watts nga circular fluorescent lamp kay na ay 1,800 lumens. And ang atong 13 watts nga CFL pin lights na day 800 lumens. So, atong nakita diri nga ang ilang lumens mo given, but not the luminous efficacy. So, ang buhaton nato ingani ato sang i-calculate ang iyang luminous efficacy if dili given ang lumens. Manta maglisod ingani og pangita kay ang total lumens sa 32 watts kay given naman, which is 1,800 lumens. But what if ang total lumens kay kanang given na pero atong gipangita kay ang luminous efficacy, or the LM per watts. So, ang atong buhatan na ni, ato na pong i-manipulate ang atong formula. From the total lumens equals W times LM per W, ang atong buhaton ni ngani is the luminous efficacy is equivalent to the total lumens all over the watts. So, according to my research, ang lumens daw per watts sa isa ka fluorescent light typically ranges from 50 to 100 lumens per watts. So, ang atong buhaton ni ngani para makuha nato ang lumens per watts ni Ja kay between 50 to 100 man, so dili si Ja exact, wata kay ba kung pila jud. So, ang atong buhaton ni ngani, lumens per watts is equivalent to 1,800 lumens according to the given, divided by sa 32 watts nga fluorescent lamp. So, mo answer na si Ja og 56.25 lumens per watts. So, from 50 to 100 LM per W, nakita nato nga 56.25 lumens per watts ang isa ka fluorescent light. So, kung ato na si Jang balikon og compute nga ang given na nato nga luminous efficacy is 56.25, so atong i-times. So, 56.25 LM per W times the 32 watts, makancel man ang watts. So, ang mapabili na lamang kay 1,800 lumens sa isa ka fluorescent lamp. Since sa atong given is usa ra man pud ka fluorescent lamp, so no need to multiply it by other numbers. So, mapabilis diyang 1,800 lumens ra. Nakuha na nato ang sa 32 watts nga fluorescent lamp. So, let us proceed to the 7 by 13 watts CFL pin lights. And the given is 800 lumens daw sa 13 watts. But according to my research, the luminous efficacy daw of the typical CFL is at a range of 50 to 70 lumens per watt. But of course, wa lagi hapon nato na ibaw-an kung pila ang iyang exact nga lumens per watt. So, atong gamito na po ng formula nga Lm over W is equivalent to total lumens all over watts. So, given nga 800 lumens daw ang 13 watts, so 800 lumens all over 13 watts is equivalent to 61.54 lumens per watts. Okay, naa ko nun tayo 61.54 nga luminous efficacy or Lm per W. Kung ato na pong gamito ng atong original nga formula para makuha ang total lumens, nga ang formula niyo is lumens equals the watt or the wattage times the luminous efficacy. Ang makuha na tong answer is 5,600 because 61.54 LMW times 13 watts. So, cancel na to ang W, ang wattage. Ang answer nga na nilang duha, i-multiply pa na to og 7 because according sa tong given, 7 po daw ka CFL pin lights ang naa. So, ang answer nga na is 5,600 lumens, the same sa atong answer sa atong example dito So, kung ato na sidyang i-add ng duha ka fixtures na to, ang total lumens sa atong fixture, so 1,800 lumens plus 5,600 lumens, mo answer na siya og 7,400 lumens overall na. So, muna itong total lumens sa duha ka fixtures na given. So, na-answer na nato ang required lighting levels, ang fixtures o total lumens sa atong fixtures. So, we're done sa atong sample calculation. Urban living trends. So, there's some definition of terms again. So, urbanization trends reference to the patterns and the rates at which populations move from rural areas to urban centers, resulting in the growth and expansion of cities. Kung may nga rural areas, manas dyan mga province or mga probinsya nga na yung mga kahumayan, mga kabukiran, nga na. On the other hand, urban centers or urban means kanang mga cities or mga kanang mga lambo nga mga towns man siya. And the urban living typically refers to residing in densely populated areas such as cities or large towns. And lastly, urban living trends. When we say urban living trends, these are the ways people live in cities and the conditions that affects their quality of life.
Smaller, higher quality spaces. The trend towards smaller, higher quality spaces in urban living refers to the movement towards compact living spaces that prioritize thoughtful, efficient design and high quality materials even in limited square meters only. So kasagaran sa mga tao nga nag-reside sa urban places, mao ni ilang priority nga bahala og kanang gamay lang ang ilang space but they ensure na quality pod ag ilang mapuy-an dito Well, instead of large apartments or homes, modern urban design is focusing on creating smaller, gagmay, yet functional and aesthetically pleasing spaces that maximize the available area through clever layouts, multifunctional furnitures, and storage solutions. Next is green design. Green design or sustainable design in urban living emphasizes an eco-friendly construction, energy-efficient systems, and materials that reduce a building's environment footprint. The challenges of green designs. The first challenge is too much emphasis on compact fluorescent light or CFL. Although CFLs were once widely promoted for their energy efficiency, they come with disadvantages or drawbacks such as lower light quality, slower warm-up times, and the presence of mercury, which possess disposal issues. The next challenge is little understanding of lighting design by utility and energy efficiency advocates. Energy advocates often focus on lowering the power usage, sometimes overlooking the importance of lighting design that meets functional and aesthetic needs. Effective lighting design combines efficiency with user comfort, considering the light placement, intensity, and ambience.
The third one is not many good choices of luminaires embodying green principles. Here, the green design ideally uses lighting fixtures or luminaires that are both energy efficient and sustainable in materials and production. But few products meet this criteria. This lack of options limits the ability of designers to select fixtures that are fully compatible with sustainable design principles. The last one is poor design sensitivity in the green community. So some proponents of green design focus more on function and sustainability than on aesthetics, which can result in spaces that feel too minimalistic or overly practical. The true green design should balance sustainability with aesthetics to create welcoming spaces that encourage wider adoption of eco-friendly practices.
I hope you have learned a lot. Thank you for listening. Padayon Future Engineer.